In this video, we are going to study heteroskedasticity with Breusch-Pagan and White tests in R. As you can see at the bottom of the screen, this is an educational video only and no professional advice is included within it. Okay, so let's go into RStudio. So the first step within the video, which we're going to comment here, is we need to load the corresponding packages. Therefore, we have step 1, which is packages. And for this, we'll be using a library function and within it the name of the package. So we'll be using AER for data, and also with library function, we'll be using LM test package, and we'll use that for Breusch-Pagan and White tests. To run these two code lines, we go ahead, select them, and then we can either click run or press Ctrl Enter on the keyboard. Then we continue with step number 2, which is data. For this, we'll be using data function, and within parentheses, we have the name of the object, which is house prices. This house prices data object is located within AER package. To run this code line, as we have a single code line at any part of it, we can either click run or press Ctrl Enter on the keyboard. So this creates the house prices object within the global environment as a data frame. And if we click on the spreadsheet kind of icon, this opens the data for us. In this video, we're going to focus on the first 3 columns of data of price, lot size, and bedrooms. And the reason for this is that we will have an original multiple linear regression in which we have price as a dependent or explained variable being explained by the independent or explanatory variables of lot size and bedrooms. If you have any questions regarding this house prices data, you can go into the Help tab and search for the object name, which is house prices. Select it, and then you'll see the documentation below. So next we can continue with step number 3, which is the model. For this, we're going to create an object name MLR, which stands for multiple linear regression, equals to LM function, and within it we have the following parameters. Formula equals to, and as mentioned previously, price as a dependent or explained variable. Special character means being explained by the independent or explanatory variables of lot size plus bedrooms, comma, data equals to, and we have the house prices object we created above. To run this code line, we press Ctrl Enter on the keyboard, and as we can see, this creates the MLR object within the global environment. So then we continue with step number 4, which is heteroskedasticity. And for this, we'll be doing 2 tests. The first of this is going to be Breusch-Pagan test. And before coding the test, we're going to comment its equation. Therefore, we have the following. Hat residuals to the power of 2 are equal to hat gamma 0 plus hat gamma 1 multiplied by lot size plus, and we follow at the next row, hat gamma 2 multiplied by bedrooms. So to perform Breusch-Pagan test, we do the following. We fit the original regression and we get its estimated residuals. These estimated residuals are the differences between the dependent variable price actual values and price fitted values estimated through linear regression. And we perform Breusch-Pagan test in which we have all these hats are because they are estimates. Therefore, we have the estimated square residuals are equal to the estimated gamma 0 coefficient, which is the estimated constant or intercept from this regression, plus the estimated gamma 1 coefficient multiplied by lot size, plus the estimated gamma 2 coefficient multiplied by bedrooms. So let's go ahead and code Breusch-Pagan test. So we'll be using BP test function and within parentheses the following parameters. First, formula equals to MLR object, therefore the model to be tested, comma, BAR formula, which is the formula describing independent or explanatory variables for the variance, no dependent variable needed. Therefore, we begin with a special character of explained by lot size plus bedrooms, comma, and we're going to press enter on the keyboard. Data equals to the house prices object we created at the beginning. This test is going to perform a chi-square test with the joint null hypothesis that independent variables coefficients are equal to 0. So let's go ahead and run these two code lines by selecting them and pressing Ctrl Enter on the keyboard, and we can see the results being printed within the console for the studentized Breusch-Pagan test. First, we have the BP test statistic. This is the Lagrange multiplier test statistic, the number of degrees of freedom, and then we have the chi-square test p-value with the joint null hypothesis that independent variables coefficients are equal to 0. If rejected, linear regression errors are assumed heteroskedastic or with non-constant variance. If not rejected, linear regression errors are assumed homoskedastic or with constant variance. So now let's continue with white test. And we're going to do this white test with cross terms. So again, we want to input its corresponding equation. So it's similar to Breusch-Pagan test. So we're just going to go ahead and copy this one and paste it here below. And we're just going to modify the differences. So with gamma 2, instead of being multiplied by bedrooms, in this case, we're going to multiply it and within parentheses, lot size to the power of 2 plus hat, and again we have gamma, but in this case it's gamma 3 multiplied by, and because we're including cross terms, we have lot size multiplied by bedrooms plus, enter on the keyboard, we continue below, hat gamma 4 multiplied by bedrooms, and last hat gamma 5 multiplied by, and within parentheses, bedrooms to the power of 2. So we have for the equation that the estimated square residuals are equal to the estimated gamma 0 coefficient, the estimated constant or intercept from this regression, plus the estimated gamma 1 coefficient multiplied by lot size, plus the estimated gamma 2 coefficient multiplied by squared lot size, plus the estimated gamma 3 coefficient multiplied by the product between lot size and bedrooms because we have cross terms, plus the estimated gamma 4 coefficient multiplied by bedrooms, and last plus gamma 5 coefficient multiplied by squared bedrooms. So let's go ahead and code this white test. Again, we'll be using BP test function. Therefore, we begin with the parameter formula equals to MLR object with the model to be tested, VAR formula equals to, here we have the formula describing independent or explanatory variables for the variance, no dependent variable needed. Therefore, again, we begin with the special character of explained by lot size plus, and here we'll be using this function, which is I within parentheses lot size to the power of 2. So I inhibits interpretation as formula operators, so they are used as arithmetical operators instead. Plus, and we press enter on the keyboard, this cross term of lot size multiplied by bedrooms plus bedrooms plus, and again with I function within parentheses, bedrooms to the power of 2 and comma data equals to house prices. So again, this is going to perform a chi-square test with the joint null hypothesis that independent variables coefficients are equal to 0. So to run these two code lines, we go ahead and select them, and then we press Ctrl Enter on the keyboard. And as we can see, this prints the results for the studentized Breusch-Pagan test. In this case, it's a white test with cross terms. We have the BP test statistic, in this case it's the white test, Lagrange multiplier, number of degrees of freedom, and then we have the chi-square test p-value. Again, with the joint null hypothesis that independent variables' coefficients are equal to 0. If rejected, linear regression errors are assumed heteroskedastic or with non-constant variance. If not rejected, linear regression errors are assumed homoskedastic or with constant variance. Okay, so with this we finish the code file, so we go ahead and save it. And with this, we finish this video. Thank you for watching.